Okay, get our brain thinking back all the way from grade 9 again. When multiplying monomials, remember mono, one term, they have the same base. So the same exponent, same base, that's the same variable. We're going to multiply the coefficients, so those are the numbers in front, keep the base, and we're going to add the exponents. So what does that look like? What does that mean? Well, if we have 5x times 3x, we're going to do 5 times 3. I'm just going to break it down for our understanding. 5 times 3 and then if we have x times x, remember that x really means the exponent 1. So that's like 1 plus 1. So we're going to 5 times 3 is 15. Numbers still multiply the same way, but exponents, x times x is really x exponent 1 plus x exponent 1 and x exponent 2, or x squared. X times x really is x, which is simplified as x squared. Taking back all those exponent rules from grade 9. Do the same thing. Negative 2 times 5 is negative 10. We look at what the actual exponent is on our variable. They both have y, that's x1, and we have 3 and exponent 2. That's going to be 3 plus 2, which is 5. So remember, y exponent 3 is really y times y times y 3 times. If we have that times y exponent 2, y exponent 2 is really y times y. If we multiply them, we really have y times y times y times y times y, which is y exponent 5. 5 of them in a row. When we're dividing monomials with the same base, divide the coefficients, so we still do division of numbers the way they used to do. All previous math still exists. We keep the base, and now the opposite of add, or partner, we subtract. So what does that look like? 6x cubed times 3, or divided by 3x. Well, we still go 6 divided by 3, which is 2. Here, we have x and we have x. We have cubed and no exponent, which remember means 1. So it's really x, top one, 3, take away 1. 3 take away 1 is 2. Remember, what that looks like, x cubed is like x times x times x, and it's all over top of x. Well, we know like x divided by x is just 1. Anything divided by itself is 1. So there's 2 of them left over, which is x squared. Super. All right. 4 divided by 12. Well, 4 divided by 12 gives us a decimal. And I don't want you putting that in a decimal necessarily, because that can remain a fraction, and it's a decent fraction. So we're going to reduce fractions. Is there a common number that goes into 4 and 12? Well, they're both even, so we could go divided by 2, but there's a bigger one. Yeah, 4. So if I go divided by 4, whatever I do to the top, I'm doing to the bottom. 4 divided by 4 is 1. 12 divided by 4 is 3. So I've reduced it. 1/3. They're both x's. I'm going to 4 take away 5, which is -1. That is correct. But when we have an exponent -1, that's kind of something funny, right? So we could also write that as like x minus 1 over 3. And x minus 1 actually brings it to the other side of the fraction. So that actually can also mean 1. And that 3 is still there, but that x exponent 1 now goes down there. And again, we don't have to show the exponent 1, so it really wouldn't be there. If that's confusing, depending on what you remember from grade 9, that is the same as that. X over 3 is the same as 2 over 3 x's. So that's why this and this fraction are essentially the same. And depending on how far you want to think ahead and reach ahead, we can do that. So, solve and check. To solve, we want to bring all of our unknowns to one side and all of our constants to the other side. So, load-bearing steps. I might show, hey, there's 5k on the left and 2k on the right. This side, the left side, has more k's, more of the unknown. So I want to get rid of the 2k from the right. That's a positive 2k. I want to bring it to 0. So I'm going to subtract 2k from the right of the equal sign. Math is super fair. Whatever you do to one side, you do to the other. So I'm going to subtract 2k from the left. 5k, take away 2k, is just 3k. That -8, I didn't do anything, so it's still there. The equal sign is still there. 2k, take away 2k, is 0k. They're gone. What remains on the right side is 7. Now I start seeing it looks like a one-step, or now it's a two-step question to find the unknown. I want to bring all the solid numbers to the opposite side as my unknown. -8, I want to get rid of that. I got to bring it back to 0. So if it's -8, I'm going to add 8, and that brings it to 0. Math is fair. Whatever I do to the left side, I do to the right side. So I'm going to add 8 to the right. 3k equals 7 plus 8, 15. To get my unknown by itself, to solve, I'm going to divide by 3, because this is 3k is 3 times 3. The partner operation or opposite operation of multiply is divide. 3 divided by 3 is 1. I just have 1k left over. Whenever I do to the left, I do to the right. Divide by 3. 15 divided by 3 is 5. So there's my solve. To check my answer, I'm going to rewrite the original question. Original equation. And underline it, find that equal sign, and drop it. Everywhere I see my unknown, I'm going to put the answer that I actually got. I'm going to treat the left side different than the right side. I'm going to solve that and get one answer. 5 times 5 is 25. 25 take away 8, 17. On the right side, 2 times 5 is 10, plus 7, 10 plus 7 is 17. Right now, those are even. That's awesome. That means the left side is actually equal to the right side, which means, in fact, I did find the right answer over here. If I didn't find the right answer, I would look at, oh, these don't match up. I was probably wrong here, or I did some math wrong here. Okay, flip the page. Let's try another solve and check. Now I gotta distribute. So remember, from previous knowledge, I'm gonna do that. And I'm gonna distribute the negative, sprinkle it in, across there. collect my like terms. 5y take away y. Minus 15 plus 2. Continue to collect like terms across the equal sign. And solve for the unknown. If I need to check, do the exact same thing. Rewrite my entire equation. Underline, find the equal sign, drop it. On the right side, that's already 19. It's taken care of. On the left side, we're going to put in 8 everywhere y is found. All previous math still exists, so now I follow my order of operations. Take care of what's inside the bracket first. 8 minus 3 is 5. This bracket does not affect that one, so I can do it at the same time. 8 minus 2 is 6. I don't really need the brackets there. That's the same as that. Because negative 1 times 6 is negative 6. 5 times 5, 25, take away 6, it's 19. Hey, look at that. Once again, the left side equals the right side. So I was correct, y equals 8. Let's do one with fractions and x's on both sides as we work through here. So, I want to get rid of fractions. Depending on how you learned how to get this, we're going to cross multiply. So we have one fraction on the left, one fraction on the right. I'm going to take 4, and I'm going to multiply it by that entire thing. So I'm going to have 4 times x minus 2. I'm going to have my equal sign. I'm going to take what's on the bottom here, 3. I'm going to multiply it across the equal sign to the entire top of the left side. So I have 3 times 2x plus 3. Now I can continue to distribute. And solve, collect like terms. There's 6 x's on the right and 4 on the left. That's more over here. So I want to get rid of the x's from the left side. Take away 4 x's, take away 4 x's. Take away 9, take away 9. Divided by 2, divided by 2. All right, look, can I reduce that fraction? No, I can't. I'm not afraid of fractions. I leave it as a fraction. That is a nice decimal, negative 8.5, but I don't want to be afraid of fractions. If I were to check, I might turn it into a decimal because it's not a disgusting one, it's not repeating, but we can check as a fraction. I'd like you to do that. Give it a try.